And we've got another partial fractions problem. This time the denominator has 3 unique linear factors. So I'm going to break it into the sum of 3 fractions. I have 2x plus 3 over x times x plus 2 times x minus 1. That's going to break into 3 fractions, a over x plus b over x plus 2 plus c over x minus 1. Now I multiply both sides of this equation by the common denominator, and on the left the denominator is going to fully cancel and I get 2x plus 3. And on the right, when I distribute my common denominator to the a fraction, the x's will cancel. So I have a times x plus 2 times x minus 1. When I distribute to the b fraction, the x plus 2's cancel, so I have bx times x minus 1. When I distribute to the c fraction, the x minus 1's cancel, so I have cx times x plus 2. Now I choose some convenient x values. I'm thinking 0. So the left side of my equation will be a 3. And then I have negative 2a plus 0b plus 0c. So a is negative 3 halves. Okay, now I'm going to do x equals 1. And so I get 5 equals, I know a is negative 3 halves, so I'm going to put that in. And if x is 1, this becomes 3 and this becomes 0. Plus b times 1 times 0 plus c times 3. So I get 5 equals 3c, so c is 5/3. Okay, my last x value that I'll plug in will be negative 2. So 2 times negative 2 is negative 4, plus 3 is negative 1. And when I plug a negative 2 in here, my whole a term goes away. If I plug a negative 2 in here, my whole c term goes away. So I just need to look at this term, plugging in negative 2. So I have b times negative 2 times negative 3. So b ends up being 1 over 6. So my integral becomes a over x, and a is negative 3 halves over x, plus b over x plus 2, so 1 over 6 over x plus 2, plus c, and c is 5/3 over x minus 1 dx. And now I integrate term by term, so I have negative 3 halves ln x plus 1/6 ln x plus 2 plus 5/3 ln x minus 1 plus c. Okay, I just noticed a little problem in here. Up here, when I was solving for b, I should have had negative 1 equals 6b, which means that b is negative 1/6. So I need a negative here and a negative here.